so how we found this. Given the 5 and the 7. First off, you know it's a right triangle because it forms a right angle here, right? Yeah. Anytime you have an angle anywhere on the unit circle and you're asked to find a theta, the process is to connect that to the x-axis and form a right angle. Okay? And then once you do that, you'll always want to use SOHCAHTOA. Okay? So from the angle, which two sides did we have? We had opposite and we had adjacent. Which trig function is that? Tangent. So it was tangent of theta equals 5 over 7, and then you took inverse tangent of 5/7, making sure you're in degree mode. And there you go. There are both radian and degree questions on your final. You're going to have to bounce back and forth. You just have to pay attention to what the question is asking for and or requires you to do. If you're putting in degrees or radians, that's what you need. If you need degrees or radians for your answer, that's the mode you need to be in. You just got to pay attention of that and be cognizant of it. Now, this question, we're actually going to jump to this one first in your today's final review. I don't remember which one it is, though. I'll find it. I wish I just made it first. Here it is. Find the direction and magnitude of AB. What do you think AB is referring to? How'd you know it was a vector? Magnitude, right. Only thing we've done magnitude with. Very good. Now, this is the exact same thing that we just did. But people probably wouldn't have thought that when they had read it. A vector, that is the component form of this vector, meaning this vector has, if it started at the origin, where would it go? Where would this vector travel? 6 right, 8 up, and this would be our vector. And it asks for the direction of the vector. The direction is nothing more than, technically this would be like north of east, but it didn't ask you for that. And that's exactly what we just did. When it asks you for the direction of a vector on your potential test, I don't know if this one's on there or not, that's what you're going to need to do. So, once again, tan inverse of 8 over 6. Somebody punch that in for me. Tan inverse of, actually I have my calculator out today. Okay, 53.1 degrees. So it has to be B or D. What's the magnitude of this vector? How did you get 10? Well, that's true, but how do you actually find the magnitude? Yeah, just Pythagorean theorem. A squared plus B squared equals C squared, and you would find that C equals 10. Yes, that's the component form of a vector. Now, I think previously we had mostly talked about it in this term. Yes. Oh, well, now you have. Different books, I think when I made, just one second, the reason I made this just a review is because I believe when I made this review, it was from the last book we used, and it talked about vectors mostly like this. But these two things are the exact same. If this had been a -6, this would be a -6. If this had been a -8, that would have been a -8. Yes, ma'am. You are. You can use anything handwritten and your unit circle on the final. So if you choose to print off those things the next 2 days, which would be good, you can follow along better, but you will not be able to use the hard copies on your test. Good question. Alright, so let's actually just start from the beginning. Austin's here!
Yay! I have my paper that I printed out in the library as passed.
Your what?
Miss Wiggins told me just to use the paper that I printed out at the past. Do you want to see it or do you?
Oh, you show me later.
Okay.
Hold on, I have to mark you present. What is this problem going to look like? Okay. What is this problem going to look like? Find the inverse of a one-to-one function. What is this problem going to be asking us to do? It is going to be asking us to find the inverse. Let's think. What ways have we found inverses this year? We've done it with matrices, but this says functions, so most likely it's not going to be that. How have we found inverses of functions this year? Switch the x and the y, which makes you think that this is going to be giving us a what? Just a function that we have to switch those two variables. And you're exactly correct. It's just going to give you a function, and you need to switch the x and the y. That is x equals y plus 3 cubed. How do I solve this? Solve for y. Take the cube root of both sides. Subtract the 3. So that'll be the cube root of x minus 3, which is a. We'll also take the next 2 days reviews on your clickers. So when you'll come in, you'll need to log into your clickers the next 2 days. Yeah, that's how you solve for inverses. You switch the variables x and y, and then you solve for y. Questions on that problem? You might need me to leave this up there? Okay. Now I've taken down the extra credit thing, the hell of directions. I've taken it down off the internet, so if you'd like to have a cheat sheet for what's going to be exactly on this final, maybe you should be good buddies with someone who's done that, and they can tell you. Number 2. Find a rational zero of the polynomial function and use it to find all the zeros of the function. What do you think this problem is going to look like? It is going to be a function. What are we going to be asked to do, basically? Factor it, find the, yeah, we'll probably end up having to do the quadratic. You may not be able to immediately do the quadratic, but we are going to have to basically just find the roots. Now, because it's a multiple choice test, there's one way you could do this. It'll be hard to plug in imaginaries. You could make these into 4 factors, like x minus 1, x plus 4, x minus this, x plus this, and FOIL like crazy. But in my opinion, the easiest way to do it is just to do it the way it says to. Find 2 of them that work, and then maybe use the quadratic to find the last 2. What's the number, bless you again, what's the number you think we should try to take out using synthetic division? Yeah, I'm thinking we should try 1, -1, 4, and -4. Technically, you need to make your P over Q's list, but hey, it's multiple choice. The answer is staring you in the face. So let's try +1. 1, -9, 48, -78, -136. This one had no missing terms, so I didn't need any zeros. Bless you. Drop the 1, multiply, add, multiply, add, multiply, add. This is not going to work. So let's try -1. -1, -10, +10, 58, -58, -136, +136, Eureka! Which options can I immediately cross off? C and B, because they don't have a +1. B is wrong, and C is wrong. Now, we can immediately know that the other whole number has to be a what? +4, because both these have a +4 in them. So, but we still need to take that out. So we're going to take +4 out, synthetically. Drop the 1, multiply, add, multiply, add, multiply. What is my, bless you, what is my depressed polynomial? Very good. That's after you factored out x minus 1 and x plus 1 and x minus 4. What can I do with this to find my last two, Drake? Since you said it earlier, bless you again. Quadratic. Negative b plus or minus b squared minus 4ac all over 2a. 6 plus or minus. Well, I keep forgetting that. Hot diggity. So what's the square root of 100? 10. And what's this going to reduce to? I'm sorry, I pre-reduced this. That's right, that'll be, crikey, I'm out of room. That'll be 3 plus or minus 5i when you divide everything by 2. So the answer is A. Now, another way you could solve that, if you're not a big fan of synthetic division, you could always graph this whole thing. And you could probably eyeball that the 1 and the negative 4 were the roots instead of the negative 1 and the positive 4. But you're still going to have to do synthetic anyway, because you still have to get down to a depressed polynomial to figure out whether it's going to be these imaginaries or these imaginaries. So all you people who are like, why didn't we do it in the calculator all year? Well, that's why. You still have to do it like this, even with the calculator. They won't give you imaginary roots. Questions on this problem? I mean, your calculator will not give you, it won't tell you what they are. I don't know. I guess there's a possibility that you could do that. I don't know how you would. But if you can figure it out, then by all means use it. Questions? Alright. Solve the polynomial equation. In order to obtain the first root, use synthetic division. What do you think? Same as last time. Yeah, it's just worded a little differently. Shabam. We can immediately cross off which option. Why? That's right. There has to be 3 roots. This one only gives 2. It's out. Let's see. What numbers do we have to try to plug in? What's another option? Yes. But before we do that, this is kind of a thinking outside the box question. We've talked about this, but not in great detail. What other option can we immediately cross off? Why? That's true, it doesn't. And the Descartes rule of signs would show you that it did. But what's the thing about imaginary roots? How do you get an imaginary number? How do you get an imaginary number? How did we get one in the last problem? We took the square root of a what? A negative. You have to take the square root of a negative number to get an imaginary number. And because you're doing that, imaginary numbers always come in pairs. You cannot ever have an odd number of imaginary answers, because that completely counter whatever how they come into existence. When you take the square root of something, you get 2. So B is also out. So what numbers do we need to try to take out of our original? 9 and negative 9. Anybody want to take a guess on which one we're going to try? Well, confident. All right, let's try the negative 9. 1, 7, negative 16, 18. Drop. Oh, we won't even need to find the imaginaries here, will we? Negative 9, negative 2, 18, 2. You were right, Troyan. And you could stop right here and assume that the answer is C using just those pieces of logic. If you, let's say for a moment that this was also negative 9 and somehow these roots were different, therefore, how would we finish this problem up? Quadratic. You take the depressed polynomial just like the last problem and do quadratic. However, that was not necessary, so we'll just stop. Any questions on that problem? How we knew something, why we did something, anything like that? Okay. I didn't plan it like this, but today is our longest review, which is good because it's the only day I'm going to have all of you, probably. Use the Pythagorean theorem to find the length of the missing sides and find the indicated trig function of the given angle. Give an exact answer with a rational denominator. What is this going to look like? It's going to be a triangle. What was the key thing? Let you know that. Pythagorean theorem or missing side, you're right. It's a triangle. Pythagorean theorem. A squared, b squared. I'm trusting by now you can do Pythagorean theorem, so I'm just going to kind of skip that step. Now, cosecant of theta. What is cosecant the flip of? Sine. From our angle, what is sine? That's right. You're going to have to know your SOHCAHTOA. Sine is opposite over hypotenuse. So that's 5 over radical 29. Therefore, cosecant would be radical 29 over 5. No reduction necessary because there's no radical in the denominator. And the answer is C. Any questions about any step we took there or how we knew to do anything? Anybody like me to leave this on the board for a moment? For the first time ever, I also think I'm going to put one bonus problem on the test. It'll essentially work like a 5-point curve if you get it right. It'll basically substitute for a question that you miss. So if you get everything right, including the bonus, it won't help you. But it'll still be nice. I forget which number it is. It'll be graphing an ellipse. Because I know I taught that and I said it wouldn't be on the final, so I'm just going to make it a bonus. But we'll get to that in a second. There's a slide for it today. Number 6. Solve the triangle. Caleb. What's this problem going to look like? One second. I'm going to pick on someone because everyone should know what this one's going to look like. I don't know why I'm going to pick on certain people. I'll pick somebody with their head up though. Didn't what's this problem going to look like? That's right. It's going to have a triangle. Very good. And we are asked to solve it, meaning find all the rest of the pieces. Now here's where it gets a little tricky. How are we going to know how to solve it? Hey, Caleb, I didn't meant to give it to you earlier. Give that one to me, please. Who can tell me what our first step needs to be to help solve this thing? Somebody other than Joe. You're answering everything. I love it. I love it, but it's a team game. And you too, Drake. You're answering everything too. Josh. Find the missing angle, and what is it? How did you get that? And it has to add 180. Very good. 75. So we can immediately cross off options B and D. Now what are we going to do? Thank you. Law of sines. How's that going to set up for us, Brian? Very good. Now, let me ask you something. We've crossed off B and D. How can you solve this problem without actually needing to do any math at all? Seamus. That's right. And therefore, which one has to be the correct answer? C. Why? I mean, say it real loud. Very good. And if these are your only two possibilities, option A has side A bigger than side C, which is impossible because angle A is bigger. So very good. So therefore, you could also conclude like that the angle was C. But we're going to go ahead and finish the law of sines, just in case that is not possible Monday. So cross multiplying. Oh, let me also say this. I saw in some of your papers during the review that when you do the law of sines, I don't know whether it's like something you're just trying to like shorthand, but I see people like leaving the sign out of it, and they're thinking, well, I just didn't feel like writing it. I've had people tell me that. But then when you work it, you forget to use sine, and you're just doing like 75 times c and 65 times 7. Sine is an integral part of this formula. If you don't use it, you're not going to get the right answer. So please remember that. 7 times sine 65 equals c times sine 75. And we're ready for the calculator. Make sure I'm in degree mode. I am. 7 sine 65 divided by sine 75. 6.57, which is what we got. So yes, the answer is C. And then you could do law of sines again to find the third side, if you needed to. But I doubt you will. Questions on this problem? I love this kind of problem because you have to know so many things. Ooh, what's this one going to look like? Taryn, haven't heard your voice today. What's this problem going to look like? It's going to look like a triangle. Very good. Who can tell me, other than Joey, Josh, Drake, and Seamus, how we're going to go about trying to solve this triangle? And Troyan. Sorry, you've spoken up a lot too. Law of cosines. Very good. I'll get you next time, Austin. Law of cosines. Very good. And before we do law of... How?
Because if you look at the degree, A is the largest one, so it has to be number 4.
Very good. So it has to be C or B.
And the second one, or B is the second largest, which means it has to be 4 times.
So the answer would have to be, ooh, I love math logic. It's so powerful. We didn't even need numbers or cosines or nothing. But we're still going to go ahead and solve it, just for the practice. Very good, though. It is C. Using the law of cosines, let's say we want to solve for side B. I don't know why we'd choose B, but let's say B. So which side needs to go by itself if we're looking for angle B? Give you... If B is the angle we're looking for, then which side are we... Or I would have also accepted the letter B. But yes, 6. So 6 squared equals 8 squared plus 4 squared minus 2 times 8 times 4. Cosine of B. That's the law of cosines when you're given all 3 sides. So that's 36 equals 64 plus 16 is 80. Not that. It's 80. 80 even. Minus 64 cosine B. What is something you should never do at this point? Subtract. You cannot subtract 80 minus 64 because 64 is married to cosine. You have to subtract the 80 first. So that's negative 44 equals negative 64 cosine B. Now you divide both sides by negative 64. That's how they will be legally separated. And then you take inverse of cosine of that fraction. Second cosine of 44 over 64. I just went ahead and canceled the negatives. 47. And you were right. Therefore, the answer has to be C. It's the only one with angle B equaling 47. Yes, ma'am. Sure. In your book, there's 3 of them, but they're the same formula. It just takes into account, depending on which side you're looking for. But it's A squared equals B squared plus C squared minus 2BC cosine A. Again, let me repeat. Don't fall in love with these exact letters. They're just placeholders. If you're looking for angle C, then C will go here, and you'll need to switch your C's and your A. So that would be c squared, and those would both be a's. That's why it's listed 3 times in your book. But there's the formula. Questions on that problem? You might need me to leave this up there. Match the point in polar coordinates with A, B, C, and D on your graph. What do you think this one's going to look like? Austin, you want to tackle this one? I'm so glad you were here today. Very good. Exactly what it is. Now, dang it, this happens to be the exact one you did on the review 2 days ago, so we're actually going to mix this up. Well, actually, I guess we'll solve this one first. Somebody tell me which one it would be. You know, I hate how these problems do this. You're thinking point A, right? But actually, letter A is option C. I hate these. Please watch this one on your test. I don't know why they didn't just make A, B, B, C, C, and D, D. That's just mean. Right? But, yeah. It's point A because the radius of 4, pi over 2 is here in a unit circle. But the negative angle flips you over the x-axis, but the negative radius flips you over the origin right back to here. So the actual answer would be point A, which is option B. Now let's do a different coordinate, because I'm getting sick of that example. Not to mention, well, never mind. Let's see. How about, I'll still stick with double negative though. Negative 2, negative 5 pi over 4. Really?
Yeah.
Great minds think alike.
5 pi over 3 is something.
That's not the same at all, actually. Okay.
Well,
All right, so you're not as good as Austin is at it. All right, radius of 2. You're more mocking when you laugh. 5 pi over 4 in the unit circle is here. So with both being positive, it would be there. What does the negative angle flip us over? The x-axis, which would put us here. Then the negative radius flips you over the, which would put you here. And that would be the correct graphing of the points negative 2, comma negative 5 pi over 4. Questions on that problem? There will be a polar coordinate question on there somehow or some way. Solve the system of equations by substitution. All right, let me just quickly say this before we even look at this problem. I don't care how you solve these systems. I don't care if you use substitution, elimination, matrices in your calculator. I don't care. However, I will be doing it the way it says in the directions just to keep things fresh. What is this problem going to look like? You could put it into a matrix, but what's the actual problem going to look like? Somebody other than my usual suspects. Savannah, what's this problem going to look like? That's right. Well, just one system of equations, but yes. There we go. Now, before we start solving this, option D, what is that? Undefined, which means it would be a no solution. So if you get like 0 equals 1, which you should have gotten on your review a day or two ago, that's what the option would be, that would be no solution. So it says substitution. I'll do it the way they ask. I'm going to solve for x on the top row. You do not have to do it like this. If you want to multiply this row by negative 3 and add it to that row, that's cool too. But just trying to appease the problem maker. Plugging that into my bottom equation, (57) minus 9y plus 2y equals 8. Subtract 57. negative 45. Is that right? That can't be right. That's going to be ugly. What is it? I'm really glad you can keep track. Divide by negative 7, and y is 7. Therefore, the option has to be B. Again, I don't care how you solve these. It's multiple choice. I'm not even going to take up your work on this test, so I really don't care. Questions? Okay. Savannah, what do you think this one's going to look like? That's right. But this one's going to step it up and go to 3 variable. How would somebody like for me to work this? We could do elimination. We could do matrices in the calculator. On the calculator or by hand? Okay. Alrighty. On the calculator, if you wanted to solve this problem with matrices, you'll need to hit second x inverse, go to your matrices. You need to make a matrix, so go over to A and hit edit. Now, first thing you're going to plug in is left-hand side, which is a 3 by 3. Oh, whoa, that's huge. Yes. Yes. Is that what that does? Oh, I've never done that. I'm going to do it both ways. What does that even stand for? Row reference? Okay. Well, no, that's what I gave you guys as a homework assignment. That's why it was bonus. Maybe you should care. Anyway, doing it this way first. Then I'll go back and do it Trojan's way. Putting in just the left-hand side matrix. 1, negative 1, 1, and 1, 1, 1, and 1, 1, negative 1. Enter. Now I'm going to put in my answer matrix, which is a 3 by 1. And that's negative 1, negative 9, negative 3. Now, if you remember, the whole point of breaking these down into matrices was like, you know how if like 3x equals 9, you just multiply both sides by the inverse of 3? Same thing. If we multiply both sides by the inverse of our original, so A inverse, so yeah, A inverse times our other side, that will give you your answers. Negative 2, negative 4, negative 3, and the answer is B. See? Well, fine. I'll do it. Jeez. Edit. I'm going to make this a 3 by 4 now and do it the Trojan way. This is probably what I'm going to call it for the rest of my career now. Negative 1, negative 9, negative 3. Now you say if I do this one of matrix. Oh, yeah. Quit. Whoa, what's happening? Clear. Negative 3. Enter. All right. My bad. Quit. Oh, I bet that's how you do it. That thing we were talking about. But you didn't. Okay. Ha! Cool. Interesting. I wonder what the REF stands for. Anyway, good job. I did not know that. So you could do it like that too. And the answer is B. I learned something today. Those are the jokes, Savannah. Learn to time your laughs. Yes, sir. Oh, it's an acronym. Well, that makes sense because that is what that's called. Thank you. I thought it was like row reference. I was wrong. Reduced row echelon form. We already did this one. Thank you for telling me that. Now I can die happy. Not that I want to die. Find the slope of the tangent line to the graph of f at the given point. What's this problem going to look like? And or what are we going to be asked to do? What? Find the slope of the tangent line to the graph at the given point. Close, but no. Seamus. That's exactly what we're going to have to do. Slope of a tangent line is where they give you a function and ask you to find the derivative at a given point. In this case, the point is 1, -3. Which piece of this problem are we not going to use at any time? The -3 is completely worthless to us. All we really need is the derivative function, then to plug in 1. Now, I saw some of you on your reviews recently, I think it was your reviews, doing the f of a plus h minus f of a thing, which is awesome. But remember, we could always just do the power rule. How would I do the power rule for this problem? Anybody remember? Finding derivative, what do you do? Try bring down the exponent, reduce it by 1. Bring down the exponent, so 11 times 1 is just 11. Reduce it by 1, so now there's just nothing. And what happens to anything without an x? It goes away. So this is our derivative function. Now all we need to do is plug in 1. So that's 2 plus 11, which is 13. Questions? Okay. Well, I'm just going to go and tell you. This is exactly like the last problem, it's just worded differently. And they didn't bother giving you y value. They just want you to take the derivative and plug in 100. How can I rewrite square root of x so I can do the power rule? X to the 1/2. Power rule, bring down the exponent, subtract by 1. What's 1/2 minus 1? -1/2, which is 1 over the square root. So you could rewrite that like this, or you could just leave it like this if you're not feeling too good about your negative or fractional exponents. And you can punch it in just like that. So we are punching in 100. Oh, hold on. Parentheses 100. Let's take 1/2 first. 1/2 parentheses 100 raised to the -1/2 power. And it looks like it's 0.05, which is what as a fraction? 1 over 20? I wonder if this will math enter. Yes, it will. And see. Yes, those are the same thing. Technically, a derivative can be, when you go to calculus, derivatives is, it's like, let me just say yes and stop talking. Your calculus teacher can teach it from there. Okay. Yes. Questions? Okay. Ooh, here's the bonus one. Graph the ellipse, and there will be bonuses, or there will be multiple choice for this as well, but it would have taken a lot of space to copy paste, so I just figured we'd graph it. Who can tell me the center of this? Might as well get the bonus if we can. It is. It's +1 and -1, the opposite of these values. So 1, -1. Here's my center. Which is going to be my major axis, my x or my y? My x, because it's the bigger number. And how far in each direction is it going to go? 4. So here and here. And my minor axis, and I'm going to go up and down how much? 3. It doesn't even ask for foci. So this should be a cakewalk if you paid attention at all that day. Connect the dots, and it'll be whichever one looks like that. Excuse me. Now, I'm guessing, I wish I still had it up, I'm guessing, since it's going to be multiple choice, that you're probably going to be looking at two of them that have the same center. So you can cross off the other two that aren't centered in the right place. And then one of them will just be tilted the wrong way. Of course, I didn't draw mine very well. But this one should have been like potato-ish, like this. And I'm guessing the other wrong answer will just be tilted up like that. So it shouldn't be rocket science or ellipsis problems. It should be fairly straightforward like that on your test. First, I went to the x and I said the square root of this number is how far you go in the x direction. So from the center, I went 4 right and 4 left. And then same thing in the y direction. I went 3 up and 3 down. No problem. The center is just like the circle. It's the opposite of the numbers with the x and the y. So it'd be positive 1 and negative 1. And for an ellipse, this number should always be a 1. I heard that the one on the ACT that you had the other day, this wasn't a 1. Is that true? Anybody took that the other day? Now let's talk about this for a second. I know we should probably just move on, but let me just draw one for you real quick. I'm not going to graph it. I just want to talk about it real quickly in case you should be taking an ACT again sometime. Might as well talk about it. Let's say it equaled 2. And let's say this one was over 50 and this one was over 8. Okay? How can you make the other side equal 1? Just divide everything by 2. If you divide everything by 2, now we're happy. That's a 1, that'll be a 100, and that'll be a 16. And you put it in an ellipse form. So just because the other side doesn't equal 1 does not make it a non-ellipse. You can make it equal 1. And they'll do other things too to try to throw you off. They'll have this in pre-FOILed form. Like this will be x squared plus 4x plus 4 plus y squared minus 4x plus 4. And then they'll put the whole thing and they'll expect you to factor it out into this and then get your ellipse formula. So, I mean, there's lots of little algebra curveballs they can throw you, but anyway, I won't be throwing you those curveballs on your test. The graph of the function is given. Use the graph to find the indicated limit and function value, or state that the limit or function value does not exist. So, Jordan, what do you think this is going to look like? Shelby said you had the answer to this one. Shelby, you lied to me.
I did not lie.
Well, can you tell me what this is going to look like? Oh, what a panic answer. Well, I'll give you a hint. I'm going to re-ask the question, and I'm going to underline the words you need to be saying out loud. What do you think this is going to look like? It is going to be a graph. And what kind of things do you think they're going to be asking us to find on the graph? You are going to have to find the indicated limit. And then you're probably also going to have to find the what? I'm not that much of a criminal mastermind, but I wish. Okay, very good. It's going to give you a function, and it's going to ask you for a limit and a function value. I think this is one we've actually had on one of our previous tests. What is the limit as x approaches 3, and why is that the limit? Well, he said 3 because as it approaches to the left it's 3. What about the right? Are they the same? Therefore, what's the overall limit? It does not exist. Therefore, the answer here is...
I was right.
Oh, that was not a movie. I actually do remember that. Dang it. Okay. And it's 5 because that's the filled in dot. Oh, yeah? Well, what's this one? And if you say it doesn't exist, you're wrong. Okay. What is this limit going to be? Listen. 2. Why? Because that's where they both meet from the from both sides. So therefore, it has to be. Hey, dang it, none of these would even need function value. What would the function value be on that problem? At 2, what's maximal value? 1. That's where the dot is. Very good. I can't believe you successfully pulled off a Mean Girls quote during my review. I feel like you've kind of won the day. Number 17. Find the indicated sum. This could be a tricky one. What do you think it's going to look like? I'll give you. Not quite. It does have that E. That's right. It has a sigma. And you know, it's funny. One of the big sororities at Murray State is like the Tri Sigmas, and every time I see them wearing their stuff, all I can think is sum. Every time. But I guarantee you, none of them probably think that. Anyway, because you know they have E. Nah, forget it. Okay. Thank you. How do I solve this? That's right. You plug in 3, 4, 5, and 6. 9 times 3 plus 9 times 4. Bless you. Bless you again. Do you need a drink of water? Okay. Add all those up. You could also do this in the calculator, but I think it's probably just easier just to do it like this. 27 plus 36 plus 45 plus 54. And the answer is 162. I'm not going to give you one that's like 0 to 40 because I don't want you to have to use your calculator. I would prefer you just do it by hand. You can do it on your calculator, but you have lots of commas and stuff. Monday, here's as far as I'll go on helping you on your calculators. If you have the function in there and it's just giving you a syntax error and your whole problem is just like with a comma, that I can help you with, or parentheses. But if you're like, hey, how do we put this in the calculator? I can't help you with that. You have to know how to do everything. I will maybe just help you with a little bit of the syntax. Only 2 more slides. I know you're devastated. Well, there are, but I've taken them out in the middle. Ooh, Sharon. Oh, wait, never mind. I wouldn't you said this. Who was it that said it was a sequence or series a second ago? Was it Jordan?
Me.
All right, flowers. What's this going to look like? What a cop-out response. What do you think they're going to be providing for us? That's right. 4 numbers. Oh, I was wrong and you were right. They are providing us with a sequence, and we have to find the first 4 numbers. So, how do we do that? What did you say? That's right. Plug in numbers 1 through 4. So the first one's going to be 3 to the first over 1 plus 1 factorial. Second one is going to be 3 to the second over 2 plus 1 factorial. 3 to the third over 3 plus 1. All I'm doing is plugging in 1 through 4 for my n values. Of course, another way you could do this is just graph it, and then you could trace 1, 2, 3, and 4. That way you didn't have to punch all these in individually in your calculator. 3 over 2, so that's going to be B, C, or D. And then 9 over 6, which is 3 over 2 again, which it has to be B or D. And then 27 over 4 factorial, 4 times 3 times 2 times 1. What do you mean? No. They just made up an equation. The n is what makes the sequence go. It's what you're plugging the numbers into. And they asked us for the first 4, so you just plug in 1, 2, 3, and 4. Yeah, they gave us that equation. You will only need one of your equations, and you will during some of the reviews. I don't think today. When it asks for when it gives you the list of numbers and asks you for either a general term or the sum, that's when you're going to need an equation. But here they gave you the equation, so you didn't. We'll have some like that in the next few days of review. Don't feel like you have to go sprinting through your notes real fast. We'll have some like that. Questions on this one? Last one. Find the products of A, B, and BA to determine whether they are inverses. Shelby, you raising your hand? What's this going to look like? So you're all over it all of a sudden. Is it because you're done making your note card? I don't either. Very good. It is going to be two matrices. And how do I find if they are inverses? What? I heard multiply. Yes, that's correct. And if you multiply them, what should they equal if they are inverses? The identity. Do we want to go calculator or do we want to go... I heard you guys did my worksheet in like 2 minutes, so how long does it really take you to multiply matrices? Wait, what? Yeah, I know, exactly. So why do you think calculators are so much faster if you did it so fast the first time? Are we having a race? I think it takes longer to punch this stupid thing in the calculator than it does. Of course, I don't have both my thumbs to use. What should you invent? Really? What would you call that app?
It's not an app, it would be on the calculator. It's probably calculator. Actually, you know what, that, it has that, I love the defense.
Yes.
In the app, that,
Yeah. The Nahadles or something like that. That's brilliant. I have never heard that suggested in my entire life. But that should work. We don't even have to put them both in. Just put in the first one, take the inverse, and if they're inverses of each other, then it should give B. Man, you're so smart. I've never thought of that. Ooh, can I math enter a matrix? Oh man! We're on a roll. Okay. And it doesn't work, so that's a stupid idea. So the answer should be B, because it didn't work. Hopefully it is. Yes, it is. Man, I never thought of that in all my years. Sad, isn't it? Okay. What? Hey, there's some truth to that. What? I really have. All right. Excuse me. A times B should equal the identity. Yeah. Okay, that concludes today's review.